Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shang, coming to you live from Summit Academy. In this video, we are working still on our unit number 5, talking about our functions, graphs, slopes, y-intercepts, and being able to talk and compare them. So the first one says bigger or smaller, and it says Diego said that these graphs are ordered from smallest to largest. Mai said that they are ordered from largest to smallest. But these graphs have no numbers on them. And it says, what do you think, Diego? What do you think Diego and Mai are thinking? Well, if you look at some of these graphs, you can tell, that some of these different slopes. But if you're thinking for Diego, you could say, well, Diego is looking at the slopes, and it has the first one is going to be negative, the second one is going to be 0 because it's horizontal line. The third one is positive, and so if we're ordering those slopes from least to greatest, that's how we would order them. However, if you're thinking for Mai, you could say Mai is looking at the y-intercept, meaning where it hits the y-axis. If you look on the first one, it goes from greatest, meaning the highest one, to the lowest one. So if we're looking at the y-axis, this one, if we give a number, it's about 5, where this is about 2, and then we could say for this one, it'd be about -3. So notice how these ones, for the y-intercepts, they're going from greatest to least. Then on the next part, we're talking about proportional relationships that define linear functions. Again, that anytime you see that word linear, make sure you're just thinking it's a straight line. So for the first one, it says Jada earns $7 per hour mowing her neighbor's lawns. What we have to do is we have to say, name the two quantities in this situation that are a functional relationship. Which did you choose to be in the independent variable, and which did you choose to be the dependent variable? Well, for this, we're going to say this. Let's say for this one, we're going to say that money is going to be a function of time. And so what we can do is we can put money on our y-axis and time on our x-axis. So make sure you can label those appropriately. Then it says to write an equation that represents this function. Well, real simple, we can say, well, we're going to have m equals 7 times t. So we're saying the amount of money is equal to 7 times the number of hours that that Jada worked. And so what that means is we're going to say that the dependent variable is going to be m, where the independent variable is going to be t. So make sure you match those up, and also notice too how the graph, we usually have the y-axis is going to be our dependent variable, where the x-axis is the independent variable. And for part C, it says, given this graph, label those axes, so we're done with that. And then we need to find at least 2 points with the input-output pairs. What that means is we can use the equation that we have right here. We're going to choose an input and calculate the output. So let me do some examples for this. So we're going to say, if we let t equal 1, what does that look like for our function? Well, we can say we have m equals 7 times 1, which is going to be equal to 7. And so what we would do is we plot that point on the graph. So we can say, well, if this is about this point on here, again, we know it has to be a point in the graph, so we can say this point is going to be 1, 7. Same idea if you pick another point, let's say let t equal 2. Let's let t equal 2. Well, we plug that into our equation, so we say m equals 7 times 2, which is going to be 14. So that creates the ordered pair. Let's have it up here. That creates the ordered pair 2, 14. So make sure you're seeing how that is set up. For the next one, for number 2, it says different problem. We're going to try to convert feet to yards. The way you do that is you multiply the number of feet by 1/3, or it's essentially dividing by 3. So it says, for part A, it says name the two quantities in this situation that are functional relationship. And which did you choose for the independent variable and dependent variable. So let's set it up. So we're going to say, well, let's label our axes. Same kind of idea. We're going to say we have the y-axis is going to be yards, and the feet is going to be the x-axis. And so that means if we let x be the feet and y equal yards, that means x is going to be the independent, like normal, and y is going to be the dependent, like normal. And so when we have to write the equation, we can say something like this. We can say we have y equals, and then just x divided by 3. So now we can draw the graph of the function. So let me draw that out. So it should look, again, it should start at our point of origin since it goes to the point 0, 0. And it just goes straight out like it did it in the last one. But what we have to do is we have to label some points. So for example, if we had x equals 3, our y value would be 1 because 3 divided by 3 is equal to 1. Then let's say another point would be, let's say you have 6, 2. That makes sense because 6 divided by 3 is equal to 2. Let's give ourselves one more point. Let's say we have 9 and 3. So make sure you can give some points on that graph. Again, notice how they are all on the line because they are solutions to this equation y equals x divided by 3. Then for the next part, it says, is it filling up or is it draining out? So let's talk about 4 tanks of water. The amount of water in gallons, A, in the tank A is given by the function A equals 200 plus 8t, where t is time in minutes. Then it says the amount of water in gallons, B, is tank B, or in tank B, starts at 400 gallons and is decreasing at 5 gallons per minute. And it says these equations work when t is greater than 0 and when t is less than or equal to 80. And then it says which tank started out with more water. So we're going to say that the tank B started out with more water since A equals 200 and B equals 400 when we start out. So again, that's going to be, we can also call this our, when t equals 0, that's our starting point. And it says write an equation that represents this relationship between B and T, so we just have to write an equation. So we're going to say B equals 400 minus 5T, because we're saying we start out at 400 and we're decreasing or draining out by 5 gallons per minute for every T minutes. Then for number 3, it says one tank is filling up while the other is draining out. Talking about A and B, which is which and how can you tell? Well, we can say that A is filling up since the slope is positive, and we know that because if we look at our equation for A, notice how that coefficient positive 8 is going to be a positive slope, so that means it's going up and to the right. However, for B, if you notice or look at that slope for B, notice how it's negative 5, so that means it is draining, meaning it's going down and to the right. All right, and then on the number 4, it says the amount of water in gallons, C, in tank C is given by the function 800 minus 7t. Is it filling up or draining out? How can you tell? Just by looking at the equation. Well, we can say it is same kind of idea as B. It's saying it's draining out, meaning as t increases, c decreases. We could say the same idea, that slope is negative because if we look at the equation, that negative 7 attached to the t is negative. So it's going to be going down and to the right. And for the last one, it says the graph of the function for the amount of water in gallon D in tank D is given in this picture. It says at time t shown. Is it filling up or draining out? How do you know? So same idea. it's draining out as t increases, meaning as time goes on, as we move left to right, the amount in the tank is going down. So we're going to say the slope is negative. So very simple. You can just be able to picture what those are doing. So on the back, starting this practice, it says 2 cars drive on the same highway in the same direction. The graphs show the distance d of each one as a function of time t. So we're saying our dependent variable is our y-axis, which is the distance, and our independent variable is time t, which is on the x-axis. And it says which car drives faster and explain how you know. So a couple things with this one. We're going to actually say that if you look at and compare at the steepness of the slopes, that's how you figure it out. So I'm talking about, how steep is this car B versus this car A. So notice how, as we move from left to right, the car B is going to be increasing faster. So we're going to say car B drives faster. The 2 cars began at the same place, but after any amount of time, car B has traveled farther than car C. And be able to see too, notice how it goes to that 0.00, so we're saying that those are proportional as well. Then for number 2, it says 2 car services offer to pick you up and take you to your destination. Service A charges 40 cents to pick you up and 30 cents for each mile of your trip. Then it says Service B charges $1.10 to pick you up, and C charges C cents for each mile of your trip. So now we have to figure out, okay, which service goes with these 2 lines. So we're actually going to say, well, if we always look at that y-intercept first. So I'm going to say that the line L, this line L, notice how it's above 1, and so we're going to say that that's going to go with that service B. So line L goes with that service B, where we could say that line A, notice how it starts, just below halfway. We're going to say A charges 40 cents to pick you up. So we're going to say that line M goes with service A. Then it says for part B and for service B, is the additional charge per extra mile less than or greater than 30 cents per mile on the trip? So we're going to say, as we move from left to right, what's happening? Well, we're going to say it is less than 30 cents because the slope of line L, which is that top line, is less steep compared to the slope of line M. So make sure you're able to see, as you move from left to right, your line L is increasing less rapidly. It's still increasing, it's still positive, but it's not increasing as fast as that line M for service A. So we're going to say that 30 cents is going to be less than 30 cents. All right, for number 3, it says Kieran and Claire like to race each other home from school. They run at the same speed, but Kieran's house is slightly closer to the school than Claire's house. On a graph, their distance from their homes in meters is a function of time from when they began the race in seconds. So make sure you can kind of be able to picture that out for yourself. So some things I can kind of draw out, I'm saying, as I have my x and y axis, we're saying this is going to be time, where this is going to be distance from house. So let me actually say from house. That's going to be your y-axis. And it says as you read the graph from left to right, will the lines be going up or will they going down? Well, as we move from left to right, our time is increasing. However, our distance from home is going to be going down. So we're going to say down for that first one. And it says what is the difference, or what is different about the lines representing Kieran's run versus Claire's run? Well, we're going to say this. We're going to say that Claire's run or Claire's line would be higher up since she started farther away from her house. And we're talking about further up or higher up, we're talking about that y-intercept. So since she starts farther home, her y-intercept or her starting place is going to be further from 0. And it says, what is the same about the lines that represent Kieran's and Claire's run? Well, we could say this. We could say the lines would have the same slope since they run at the same speed, meaning they are parallel lines. So anytime you see that word same slope, just make sure you're thinking they are parallel lines. And for the last one, we're trying to write the equation for each line. And so we're going to say, well, I'm going to start us off. I'm going to do one at a time here. But let's look at this red line, find out where it hits the y-axis. So we're going to say our y-intercept is, so we're going to say b. Let me actually write this out. Again, each of these equations are going to be in the form y equals mx plus b, where m is slope and b is y-intercept. All right, so find your y-intercept. We're going to say, hey, it goes to the point 0.05, and then we can count. So I'm going to say, well, I go one step to the right for every 2 steps up. So let's say 1 step to the right, 2 steps up, something like that. So we're going to say our slope is going to be 2. So we're going to say for this one, our function is going to be y equals, draw like this. We say y equals 2x and then plus 5. So make sure you can replace your values for m and replace your values for b when it's real simple like that. For our yellow line, same point, it goes through the point 0.5. And also too, you got to be careful though. Notice how it is going down and to the right. So it goes down 3 for every 1 step right. So that means our yellow line, or our yellow function, is going to be y equals negative 3x plus 5. Again, you can always check, I would say always check using Desmos. That way you can see what the lines should look like compared to what you have. Then for our black line, let's find where that's at. It's down here, so we're going to say, hey, that goes to the point, this is negative 6, and it moves 1 step right for every 2 steps up. So we're going to say our black line is going to be y equals 2x and then minus 6. So notice how also too, a key part that I want to point out is that the red line and the black line are both parallel. They are both parallel lines. And that makes sense because if you look at their slopes are both the same, and in the picture they do not intersect. All right, so now what about our green line? Well, our green line is going horizontally, so we're going to say, let me actually write that down. It's a horizontal line. What that means is we have to have y equals a number. So we're going to say this goes to the point negative 2. So we're going to say that it goes through the point, or our equation is y equals negative 2. Then for our blue line, we're going to actually say this is going to be a vertical line. Vertical, that just means we have x equals a number. So find where x is at, so that's on 5. So we're going to say x equals 5 is going to be our blue line. So make sure you can go from the picture to the equation, so that way you have it. Lastly, let me display the translation for the exit ticket. So in your exit ticket, it says in a certain city, France, or a certain city in France, they gain 2 minutes of daylight each day after the spring equinox, usually in March. But after the autumn equinox, usually in September, they lose 2 minutes of daylight each day. And it says which of the graphs is most likely to represent the graph of the daylight for the month after the spring equinox. And then let me write this down too. This is exit ticket. That way I can see the pictures. And it says which of the graphs is most likely to represent the graph of the daylight for month after the autumn equinox. And lastly, why are the other graphs not likely to represent either month? So make sure you can read it for yourself. Again, be sure to ask questions as always, and be sure to super slam that subscribe button.